Hello everybody, in this video we are going to talk about exponential functions and their graphs. More specifically, we're going to discuss the different kinds of functions and graphs. We're going to talk about how to create our own exponential graphs and some of the key features that we can identify from those graphs. So before we can get started, let's talk about an exponential function form. So how do we know whether an equation or a function is going to be exponential? So if you look right here, it is always going to be in this form. Now, on the left side, you see this f of x, but know that it could be y equals, it could be g of x, h of x. This is just the name of the function. But the thing that does make it an exponential is all this stuff right here on the right side. So usually when we're looking at an exponential function, you're going to have an a and a b that are represented by numbers. So the a and the b are just in the place of numbers. It could be positive, negative, fractions, or decimals. Now the thing that will make it stand out is this x right here. Our x in this function is actually the exponent. So that's why we call it an exponential function, because the variable in this case is an exponent and not a coefficient or not just a variable. Okay, so there's a couple things that our equation tells us about the graph if we're looking at the equation. This a in the front is always going to be the y-intercept of the graph. So if you graph this out, this number is going to be where the graph actually crosses the y-axis. So let's go ahead and write that in. A is the y-intercept. And so that is going to always be 0, and whatever the a value is the point where it actually crosses. Okay? B is actually going to be the one that tells us what direction the graph is going in. So our graph can either go up or go down. And so depending on which way it goes, we either call it exponential growth or exponential decay. But the b, what type of number b is, will tell us which one of the two it is. Okay? And then lastly, you don't see it here, but if there was a number that's being added or subtracted over here on the outside, that would actually be the invisible line that we call an asymptote. So I'm just going to put right here whatever is being added or subtracted. That number at the end is actually a horizontal asymptote. So keep in mind, if we ever talked about this in class before, that this is an invisible line that your graph will never cross or touch. So it kind of guides us on how this graph kind of, as it gets closer to this horizontal line. And we'll look at it on a graph so it makes a little bit more sense. So let's talk about the direction of an exponential function. Like we said, it can either be going up or it can be going down, and we call it exponential growth and decay. So specifically, if your graph is going upward, now remember, you read a graph like you read a book, from left to right. So if you start on the left and you work your way to the right, you have to ask yourself, is your graph going up or is it going down? Now for an exponential function to grow, that means it is increasing from left to right. So we're going to write that in. So it's increasing from left to right. And in order for that to happen, this b value has to be a number greater than 1. So I'm going to write that in and say b is greater than 1. So that can be anything from 1.1 to 2, 3, 4, 10, 100. So as long as the number inside the parentheses is greater than 1, then we know that this graph is going to grow exponentially or increase from left to right. So naturally, when we look at something that says exponential decay, we know it's going to be the opposite. It is not growing, it is decreasing from left to right. So let's go ahead and write that in. Decreasing from left to right. Now, we know that in order for this to decrease, b cannot be a number greater than 1, because that means it is growing, it is increasing. So it is going to be a number less than 1, but it can't be negative. So for this one, we're actually going to write it out and say that b has to be a number that is between 0 and 1. So the only numbers you're going to find between 0 and 1, number 1, are all positive. And number 2, they're either going to be fractions or decimals, like 0.25, 0.50, 3/4. Those are the kind of numbers that you're going to find between 0 and 1. So if you want to know which direction your graph is going in, you're going to have to specifically look at the b value, which is going to be the number inside the parentheses. And so from here, I have a couple examples. So let's go ahead and look at what we have on our screen. All right, so as you can see, underneath the exponential growth, we have a exponential function. So from here, we know that our b value is 2. And 2 is greater than 1, so we know that this is going to grow from left to right. So the first thing I'm going to do is I'm actually going to identify our y-intercept. So over here, I'm going to say y-int is the 3. So we're going to say 0, 3. We know that it is growing because 2 is greater than 1. So it is going to be exponential growth. It's going to grow from left to right. And because we don't have a number that's being added or subtracted here at the end, that we know that the horizontal asymptote, so I'm just going to put HA for horizontal asymptote, is going to be a horizontal line. So we're going to say y is equal to 0. That's going to be the same thing as your x-intercept, not your x-intercept, your x-axis. So we're actually going to use the x-axis as a guide to graph this out. So let's go ahead and look at the first one. So from here, if I'm trying to find some points so I can graph this out, I could actually plug in a couple of them. But before I do, I'm going to start off with the first point, which is 0, 3. So find positive 3 on the y-axis, and this is where our first point is going to be. I highly recommend picking a couple points to the left of the y-intercept and to the right. So I'm going to create a table. And I'm actually going to create my table up here. This one was already added to the graph, so there's no need for us to do that. But let's go ahead and do a -2, a -1, and then let's do 1 and 2. Alright, so with that being said, we can actually just type these into our calculator. So that's exactly what we're going to do. We're going to use the function, and we're just going to replace this x with these numbers. So the first thing I'm going to do is I'm going to do 3 times 2. And if you don't know how to do exponents, you're going to hit this little arrow right here, and it's going to give you this little box, so you can raise it to whatever power. And in this case, we're going to type in -2. Okay, now that we have it in, we're going to get 3/4. If you want to change that to a decimal, I think we just hit Control Enter, and it gives you a 0.75. So we're just going to write that in, 0.75, and then let's do that again. Let's do 3 times 2. We're going to raise it to the -1, and we get 1.5. Okay, 3 times 2 raised to the 1 power is a +6, and then 3 times 2 raised to the 2nd power. So these are my exponents right here. These are going to take the place of the x, and we get 12. All right, so if you look down here, we're actually going to use this to create our graph. So I think the positive numbers are easier to graph, so let's go to +1 and then up to 6. If you go to +2, we don't have enough room to go up to 12, but we know it's going to be up here somewhere. Okay, don't forget to do the ones on the left. So if you go all the way to -2, notice it gets really close to 1, but not quite. Like this. And then if you go to -1, you're going up 1.5. And because we have a horizontal asymptote, I'm just going to remind you that that is a horizontal line right here. So what does that mean? When you create your graph, please make sure not to touch or cross this horizontal line. So I'm going to actually curve this up from my y-intercept like this. And then I'm going to curve it down. And then notice that I'm just going to kind of glide next to the x-axis, not touching or crossing it. So this is what my graph looks like. Now, we have some things that we need to answer underneath it, but let's just worry about our graphs for right now. So I'm actually going to ask you to do the same thing with the exponential decay problem. Notice that our b value is 0.5, so that means that our graph is going down instead of up. So from here, we now know that the y-intercept is automatically going to be 0,2, because our a value is always the y-intercept, because 0.5 is between 0 and 1, then that tells us that it is decaying and decreasing. Now, because this one also doesn't have a plus minus at the end, we now know that our horizontal asymptote is also going to be y equals 0, which is the x-axis. So we will create another line right here that will allow us to guide our graph. So let's go ahead and create a table and plug in some points. Alright, so I went ahead and created my table. I'm using the same numbers because when it comes to exponential, you want to use the smaller numbers. So with that being said, let's go ahead and type it in. We're going to do 2 times 0.5, and then I'm raising it to the -2, because remember, our x value is an exponent. So we do that and we get 8. So this is going to be 8 right here. And then if I do 2 times 0.5 raised to the -1, I get 4. And then if we do 2 times 0.5 raised to the 1 power, we're going to get 1. And then if we do 2 times 0.5 raised to the 2nd power, we're going to get 0.5. Okay. So I'll put 0.5. We can clearly see that these numbers are going down instead of up. So let's start with our y-intercept. So remember, our y-intercept has already been given to us in the equation. So 0,2 would be here. This is our y-intercept. Let's go ahead and graph the rest of them. So if you go to -2, you have to go up 8. -1, +4. 1 and 1, and then if you go all the way to 2, it's just a half. Now keep in mind that this is our horizontal asymptote, so we're not allowed to cross or touch that line. So I'm going to go ahead and connect my dots like this, and then remember that this is just going to glide next to the x-axis. And we can clearly see that because this one had a b value that was between 0 and 1, our graph is decreasing from left to right. So remember, you're reading your graph like you read a book. Now there's a couple other things that we need to identify about this graph, so I will see you guys in the next video.